Hey everybody, Mr. Novak here. Today I'm going to talk about cancer. So we get to talk about how does cancer occur, what are some likely causes of it, and then um, looking at maybe how to treat it a little bit. So I know a lot of you have dealt with cancer, maybe in health class or something like that, or maybe you have somebody in your family that has cancer, has had cancer. And so this is kind of one of those topics that we can all kind of relate to a little bit because we've had some experience with biological sense. So cancer is basically what happens when uncontrolled cell division occurs. Okay, so we have our cell cycle. There are different checkpoints in our cell that say, hey, stop dividing or you're done dividing. When those kind of get messed up, we get cells that just keep dividing over and over and over again. And that is cancer. Okay, so we can see that tumors, right, these lumps of cells, begin with a single cell that just reproduces by mitosis, but then it never stops and just keeps going and going and going. All right. Metastasis, I believe that's how you say that, is a process in which the cells then move to these lumps of cells move to other parts of the body, become cancerous, and then it just keeps dividing and taking over different parts of your body in that way. So here's our cell cycle again. You can see all the different parts, the S phase, G1, G2. There are checkpoints here that I mentioned before that basically tell the cell to either stop dividing or, yep, we're good, keep dividing, right? So whenever those checkpoints get deregulated, right, they get messed up in some way, shape, or form, um, cancer will occur. Okay, so if we look at like, hey, when cell division occurs, right, there's a checkpoint that says, hey, did this actually divide? Yes, keep going. If it doesn't, no, we need to stop. And sometimes those cells will normally get destroyed and ruined. And if that doesn't happen, cancer can occur, and then multiple cells will just keep dividing over and over. Difference between normal cells and cancer cells, right? There's a difference we see as well. I can kind of see, like in a normal cell, you have a large cytoplasm. They look real healthy, robust, right? Just a single nucleus with nice chromatin in there. Whereas in cancer cells, these cells are like a smaller cytoplasm, right? They might have more nuclei because the division process didn't happen properly. The chromatin isn't quite as accurate as well either. So there are some differences there. So how does it happen? Again, we have these genes, we have these checkpoints. So oncogenes or tumor suppressor genes. Basically, they either get turned on and off incorrectly. So oncogenes help with cell growth and gene transcription. When they get activated continually, right, they're going to help cells grow and grow and grow and grow, right? So these oncogenes usually get turned on and off when it needs to. And then when that process doesn't happen correctly, we get this insane cell growth leading to then cancer. Same thing kind of with tumor suppressor genes, right? We have these genes that basically help repair the cell, control the cycle, say, hey, these cells aren't quite right. We need to destroy them. When they're inactivated, that those checkpoints then aren't happening. And so what normally would happen is if you have some cells that don't quite divide right, this mechanism, this tumor suppressor gene will say, hey, this cell isn't right, let's destroy it. If they are inactivated, well, now that it doesn't happen. So it says, hey, these cells aren't quite right. Nothing stops it. Keeps dividing incorrectly. And we end up getting that cancer happening. Okay. So again, tumor suppressor genes are really important. Often we call it guardians of the genome, right? They're maintaining that integrity, right? The DNA integrity, the chromosome segregation, making sure everything separates properly. Okay. When they mutate in some way, shape, or form, what ends up happening is that we see it usually is like the first mutation when we are developing cancer. Right? And they've analyzed the process and they see that there's this like P53 and RB. There's this whole chain of events that occurs, and then those are the genes. And those are the areas that are actually getting ruined first. That is leading to cancer. So we talked about mutations. A little mutation is change in genetic makeup. Um, a mutagen is a mutation, right? Or it causes a mutation. If you have anything that causes cancer specifically, it's called a carcinogen. Okay, so a little bit different there. Some viruses can cause it, and some bacteria can cause it, but oftentimes it's actually like a lifestyle risk. Okay, so your DNA needs to get messed up, right? And those pathways and those genes don't get made correctly. And so a lot of times it's these lifestyle risks that are leading to it. Okay, you can see on the slide here that there are a ton of different lifestyle risks. Okay, big one you probably have all heard is tanning and sun and UV rays, right? And so being exposed to that, what happens is these sun's rays over a long period of time, or tanning booth rays over a long period of time, will actually break your DNA apart. Okay, and then the base pairs won't pair correctly, or they'll get mutated a little bit and change a little bit, or something else will happen there. And then that leads to incorrect DNA, incorrect genes. Those pathways get messed up, and cancer could occur. Okay, different chemicals will do this as well. You can kind of see jobs being exposed to chemicals, or smoking the stuff in smoking, or cigarettes and vape and all that. They're finding those will mess up pathways as well. Okay, and so lifestyle risk is a really big one, okay, or environmental risk, right? So if you're exposed to that secondhand smoke, you live in areas where it's super foggy, or air pollution and stuff like that is a big one. You'll see a lot of people in areas where the air pollution is really bad wearing masks because of that. It's an air quality thing. They don't want to be exposed to that. Some cancers can be inherited, but generally speaking, you don't inherit cancer. So if your mom has breast cancer, you're not going to get it necessarily. You might be more susceptible to getting it, but those lifestyle risks is what's really kind of going to push you over the edge. So kind of being aware of that, like, hey, this runs in my family. I got to be aware of that, and it kind of lessen my risk. My dad had kidney cancer many years ago now. That doesn't mean I'm going to get it, right? But I need to be aware of that and be like, hey, I probably shouldn't do some things, or to lessen my risk to it. And you've talked about the treatment, chemotherapy or radiation. A lot of times, what they'll do, they'll try to like cut out the cancer, right? So they cut it out and they treat it with chemicals to kill the cells. And what they're looking for are these fast dividing cells and things like that. And so we see that it affects this whole body, because there's a lot of areas in your body that have fast dividing cells. And so when you have chemotherapy, um, they look at these fast dividing cells, your hair and your stomach, and that's where people start to lose their hair and things like that. But it is really important to do like a cutout and a chemical treatment, because it's like a two-prong approach. And so that's what they kind of look at for treatment. And that's what I have for you today.